Hello everyone, my name is Rajesh Kumar and I am the founder and the chief trainer of IOT. Today I am going to present about the NB-IOT NTN crash course. So welcome you all. Here we are going to discuss about the completely new technology that is called as a NTN non-terrestrial network. So non-terrestrial network is currently is available with the NB-IOT and with the 5G as well. But here our complete focus is with respect to the NB-IOT technology. So let's move on. Okay, so in NB-IOT NTN module, we'll discuss about the total 9 module I have designed in this course. So module 1 is completely about the introduction. So we'll discuss about all the concept of the NB-IOT NTN. Okay, we will see that what are the new changes has been introduced by the 3GPP with respect to the terrestrial network. Then we will discuss about the new band which is introduced for this one, and we'll see all the hierarchy or the architecture what it has been changed here. Okay, so module 2 will discuss about the industry use case. So there are several use case is exploding. Currently industry is exploding, so we will see each and every use case one by one, and that how the basically the IoT device can help in this use case. Module 3 we will discuss about the flow diagram, that how basically UE is going to connect with the satellite and satellite to the again the E node B, right? So we will see in this diagram. Then we will have the architecture. So we'll see that how it's different with respect to the terrestrial network architecture, and the type of architecture 3GPP has defined, right? So we'll see that what is the difference between these architecture as well. In module 5 we will discuss about all the operating band which 3GPP has recommended, and we will see that how we are gonna basically calculate the downlink frequency ERFCN for this one. Then module 6 will completely focus on the RAT functionalities. We will see that basically the how the contention based RAT triggers, and we'll also see that what are the difference uh, with respect to the TN versus non-TN. Okay, we'll also see that how the UE basically initially calculates the TA initial value, and how it manages the propagation delay. Okay, so that is the main concept which we will discuss in the RAT functionality. And module 7 is all about the test setup. So in this lab setup we are going to use the MDSoft setup. So we will have the UE simulator as a MDSoft and the network emulator as a MDSoft. Okay, so we'll see that. Module 8 is completely we are going to discuss about the test case configuration. So we'll see from the UE perspective. We also see from the eNodeB perspective what are the configuration which we need to perform to validate this test case. The module 9 and the last module is about the test case validation. So once we have configured the test case, how we can validate the test case, whether this is working as per expectation or not. So let's move on. So first module is introduction. So welcome you all. Okay, so as we know that name itself specify it is narrow band IoT. So this is one of the type of the IoT which we can say that we have 3 category of the IoT. Okay, one is that called that narrow band NB-IOT, second is called the guard band GUARD guard band, and the third one is called the inner band or a standalone, not the inner band, it's a standalone. Here our complete focus will be on the narrow band IoT. Okay, so what exactly we mean by the narrow band IoT NTN? Okay, so this is the combination of the two words NB plus IoT. NB stands for narrow band, IoT stands for Internet of Things. Now why it is called the narrow band, that is the important which we need to understand it. Narrow band because if you see the carrier bandwidth, it is 180 kilohertz. At the same time, the cell bandwidth used is 1.4 megahertz, and that is why it is used as narrow band, because its bandwidth is very less. Whether it's a carrier bandwidth, whether it's a cell bandwidth, it is low. Then next thing, IoT. What does it mean by IoT? IoT stands for Internet of Things. Let's try to understand what does it mean. So it is a network of physical object embedded with what? Sensors, the software, the processor, and the connecting module. And that is how IoT is defined. Internet of Things is defined. Okay. So look at this, the introduction part, what it tells. NB-IOT is a low-powered wide area network. Low power, it means that all the NB-IOT device consumes low power. Since it consumes low power, so IoT device battery life remains very long. Okay. The next thing is that it connects a vast number of IoT devices. What does it mean? It means that it can connect the huge number of IoT devices. Okay, it could be on the millions of IoT devices can be connected with the cell or eNode B. Okay, so when it comes with the NTN, that is called the terrestrial non-terrestrial network. So till now we have used NB-IOT with respect to the TN, that is terrestrial network. Now we are going to integrate with NTN, that is called non-terrestrial network. So primarily it is all about satellite communication, right, which helps us to expand its coverage in the remote or rural area where terrestrial network cannot provide the coverage. Okay, let's move on. Now next thing is that how NB-IOT operates over NTN. Okay, so there are different mode has been defined by the 3GPP for the operating mode. So 3GPP has defined 3 orbit. Okay, 3 orbit. So number one is called LEO, low Earth orbit. Second is called MEO, MEO, mid Earth orbit, and the third one is GEO, GEO, that is geostationary orbit. So we have the LEO, we have the MEO, and we have the GEO, geostationary orbit. Okay, mainly if we talk about the NB-IOT NTN perspective, LEO is mostly suited. Why it is suited? Because the altitude of the LEO is less compared to the MEO and the GEO. Hence, the latency requirement is less. Or we can say that is a lower latency we achieve in this case. Okay. Now let's see the network architecture, right? So look at this. The IoT device communicates with the satellite instead of the terrestrial base station. So here UE is not directly communicating with the eNode B. Here, rather than it communicate with the satellite and then satellite to the eNode B, and then vice versa occurs. Okay. 3GPP basically standardized this NB-IOT over NTN in the 3GPP release 17. Okay, so we can see that release 17 onwards this feature started to support. Okay, now we will see about the NB-IOT, the bandwidth, the summary, right? So look at this, the carrier bandwidth which is used is 180 kilohertz, right? It means that it consumes 1 PRB, 1 PRB. 15 multiplied 12 will give you 180 kilohertz. Okay, then we talk about the cell bandwidth. It is 1.4 megahertz is the minimum requirement for the RF processing and the filtering part. Now look at this uplink and the downlink duplex mode. It can support half duplex FTT or TTT. Based on the deployment scenario, based on the configuration, we can see this. Next is deployment mode. So we have the multiple way of the deployment. So we can deploy it on the in-band mode, we can deploy in the guard band mode, and we can also deploy in the standalone mode. Okay, now a very important question comes or should comes in our mind is that why 1.4 megahertz cell bandwidth in the NB-IOT including NTN. So let's try to understand it. Even though NB-IoT use only 180 kilohertz, means the carrier bandwidth is 180 kilohertz, the cell bandwidth must be at least 1.4 megahertz. Why 1.4 megahertz? To meet this below criteria which is defined by the 3GPP. Number one is that RF filtering requirement should satisfy. Second is synchronization and reference signal generation purpose. And third is given by the spectral mask and emission compliance has to be followed. That is the reason the minimum cell bandwidth requirement is 1.4 megahertz. Hope the concept is clear. Thank you guys. See you in the next module.